Welcome to the Tier 4 Locomotive Training. My name is Lisa. It's nice to meet you. I'm a trainer here at BNSF, and I will help lead you through the virtual simulation. Before we get started with our task at hand and job assignment, it's always a good practice to perform a locomotive walkaround. We do this to familiarize ourselves with the surrounding environment while identifying several safety-related objects. Follow me, and we'll begin our walkaround. Check to be sure derails are locked in the up position over the rail at both ends of the track the locomotive is on. Aim at and pull the trigger to select them. Check to be sure the handbrake is set, or that there are wheel chocks in place to keep from free locomotive movement. Lastly, we need to be sure the locomotive has a blue signal stanchion applied to it in compliance with FRA standards. Great! Let's move on to our task at hand discussion. Before we start working, we should fill out a task at hand and job briefing checklist. The idea of the task at hand is to identify present and potential risks within the work we will be performing. In this case, we will be on the locomotive number 3924, and we will be removing or installing an HP fuel pump on a Wabtec locomotive engine. On the left-hand side categories, you will find BNSF's 5 critical exposures. Then on the right-hand side of those exposures will be risks that are or can be associated with the task you will be performing. In the next section of the sheet, we should briefly explain precautions you will take to control or eliminate each risk identified as previously mentioned. Lastly, we should list our job-specific PPE required for our specific tasks, verify that we have the correct tools for our task, inspect those tools, have a briefing with our fellow coworkers, establish blue signal protection, and perform a job-specific briefing. Go ahead and get started. Start with the line of fire and release of energy associated risks. We absolutely have pressurized systems, as this HP fuel system is capable of producing close to 33,000 psi. Our locomotives are more energized with electricity than they have ever been before. Knowing this system's capability, let's be sure to establish our lockout-tagout tag on the battery knife switch before starting work. Let's all do our health a favor and protect ourselves from chemical exposures with proper personal protective equipment. While working, always be aware of your body positioning in reference to momentum changes, moving equipment, and pressurized or energized systems. Let's take care not to let any of the residual fuel in the system contact our skin in the disassembly steps. Now equip your specific PPE. Before we finish our task at hand, we should ask ourselves the following questions. Do we have the correct tools for the task? If not, we should challenge the status quo to gain correct tooling. Have we or will we inspect our tools? Did we brief with coworkers that will be within our work area? Have we or are we going to establish blue signal protection? Have we performed our job-specific briefing? This is what the completed task at hand will look like for the current module. Be sure to fill out your own task at hand in a similar manner. Now that we have verified the derails are up and wheel chocks are in place, go ahead and apply blue signal protection. The next steps in our process are depressurizing and de-energizing the high-pressure fuel system. Before we begin, we'll need to drain the fuel from the system. Vent the low-pressure fuel system by opening the fuel filter drain valve and fuel filter canister vent valve. Allow fuel to drain back to the fuel tank for 15 minutes. Now that fuel has drained from the system, let's head to the cab. The next step is to check the monitor parameters for the high-pressure fuel rail pressure. Aim your laser at the SDIS screens and pull the trigger to get started. The SDIS operating level is at Level 1 access. However, to inspect rail pressure, Level 2 access must be enabled. To do so, you will need to utilize a Diagnostics access switch by flipping the spring-centered switch behind the rear cab wall doors. Now open the rear cab wall doors. In the top right of the compartment, flip the spring-centered Diagnostic access switch. Now we'll go back to the SDIS screens. The SDIS screens indicate that we now have Level 2 access. At this point, press F7 on the left-hand screen to access the Loco Monitor option. Now press 4 to access engine functions. The fuel rail left and right pressure readings are 473 bar and 475 bar respectively. This is too much pressure to safely work on the system. Therefore, we must depressurize. Exit the cab to get started. Start depressurization by loosening the 3 clamps holding the left bank high-pressure fuel line to the crankcase and cylinder head. Hold the impact wrench up to the bolt heads on the clamps to do so. Hold the impact wrench up to the bolts to loosen the 3 clamps holding the left bank high-pressure fuel line to the crankcase and cylinder head. Loosen the pump to L6 cylinder line connection on the left bank high-pressure fuel pump slowly to 45 degrees in a slow, controlled manner. To do this, hold the torque wrench up to the connection and pull the trigger lightly. Now we must wait for 5 seconds before rotating the connection an additional 90 degrees counterclockwise. Sometimes you will hear a distinct sound, indicating the fuel has been relieved. Great work! Now let's go back to the cab to inspect the rail pressure. Now that the system has low enough pressure, it is safe to continue. Next, you will need to shut off all of the breakers. Let's go there now. Shut off all of the breakers. These include the Local Control Circuit Breaker, LCCB, and the Battery Charge and Computer Circuit Breaker, BCCB. Next, access the battery knife switch. Now hang your LOTO tag on the switch. The final task for the de-energizing process is to flip open the battery maintenance disconnect in the auxiliary cab. First, you must exit the cab. Opening the battery knife switch is necessary but not sufficient to completely de-energize the locomotive. Key circuits that remain energized while the maintenance battery disconnect is closed include circuits for some display lights, emergency lights, radio, handbrake, EFI, PTC, and locomotive communications. We will now de-energize those remaining circuits by opening the MBD. Great job! You have successfully completed the prerequisites required to operate on the high-pressure fuel system.